In the case of CO2 molecule, you can have a number of mode of vibrations are 3, you can say. Okay. Okay, so see, this is the, you can say, introduction of character table, where X, Y, Z represent mode of fire activity, Rx, Ry, and Rz represent rotational component, and you can have X square, Y minus Y square, or you can say Z square, or X, Y, Y, Z, and XZ. So this represent Raman activity. So that is we have completed. Now, apart from that, you can have a see also look at here. So you are having see character of E is there, so that is we call dimension, and A1, A2, B1, B2, all these are the, you can say it is irreducible representation, and we have taken 5 important rules of orthogonality theorem. And the first one is you can have a see number of irreducible representation is equal to, you can say, number of class, that is 3 in this case. Then sum of the square of the dimension of each irreducible representation, which is also equal to order of group. And also you can have a say order of group by simply making sum of coefficient of each class. So you are also getting order of group. And then in a character table, see, at least one representation should be such that it's all the character are unity. So that is we have already checked in C3V character table, that is A1 is there where all the characters are unity. And last one very important point is two irreducible representations are always orthogonal to each other. Two representations are always orthogonal with respect to each other. Now, next, see, very important one is how to getting, you can say, how you can calculate reducible component, how you are getting, see, what is reduction formula, how you can apply that reduction formula. So that is one of them. And second one is you can have a reducible component. So how to calculate reducible component? So before starting that, see, because of some limiting features in this license versions of PowerPoint, so we move to the calculation of number of number of higher active mode of vibration in the case of C2V point group, or in the case of C2V character table. See here, this is a C2V. So look at here. See, if you want to calculate higher active mode of vibration of formaldehyde, which belongs to C2V point group, then how it is possible? So see, first you draw the structure of formaldehyde here. See, this is the structure of formaldehyde, where 2 hydrogen and 1 oxygen is there. How many atoms are there? Total number of atoms?
4.
4 atoms. And see, formaldehyde belongs to C2V point group. So here you can have a, see, first you write down the trace. Okay, first, okay, or you can write down the, how to write down trace, how to write down unchanged atom. See, first you will go for unshifted atom. Okay, उसके बाद चलो शिफ्ट ट्रेस लिखिएगा. अनशिफ्ट एटम, पहले आपको ये अनशिफ्ट एटम लिखना है. Okay, number of unshifted atoms. So unshifted atom means if you are applying E operation, so out of these 3, how many atoms remain unshifted?
2.
All three. See, because if you are applying E operation, E, that is identity, that is nothing is doing molecule. So you can have a, see, number of unshifted atoms are 3. Now you go for applying C2 rotation about the C2 axis. Okay, so how many atoms remains unshipped?
2.
2. Carbon and oxygen remains unshipped, and remaining 2 can change their position. So here unshipped atoms are 2. Now then you can go for sigma xz and sigma yz. Two planes are there. So sigma xz is, suppose this is the mirror plane. You can have this is mirror plane, and this is a xz. It is called sigma yz, and this is suppose sigma xz. So if you are applying this mirror plane, then again how many atoms remain unshipped? 2 atoms, because plane which is passing through carbon and oxygen. Okay, and if you are applying sigma yz, then what happens?
4.
All 4 atoms remains unshipped. See, if you are applying E operation, so E operation, all 4 atoms remains unshipped, not 3 but 4. Because see, this is a formaldehyde having 4 atoms, so all 4 atoms remains unshipped. So in this way, you can write down the number of unshipped atoms first in order to calculate higher active mode of vibration. Now, second step is to write down trace. How to getting this trace? So see, this trace is written as simply, it is nothing but written from translation component. Translation component is a x, y, and z. Now on those representations where x, y, z are there, you can make simply sum of its character. Suppose the a1 having z, so its character is in E, its character is 1. Then a2 does not have x, y, z. So a2 does not contribute in trace, or you can say in translation component. Then B1 having X. So see, this is B1 which is having X, and B2 having Y. So see, these are the X, Y, and Z. So you can simply do the summation. 1 plus 1 plus 1, that is 3. Similar way, see, you can do the summation of these 3 characters. 1 minus 1 minus 1. So its value is minus 1. Okay, what is summation of this 3 in X, Z? 1 plus 1
1.
minus 1.
1.
It is 1. Good. And here it is 1 minus
1.
1, 1, that is 1. So see, in this way you can write down the trace. Okay, first you have written unshipped atom, then you have written trace. After that, then you go for write down, see, tau 3n, 3-dimensional degree of freedom. So that is written simply by doing multiplication of these through unshipped atom and trace. You can multiply unshipped atom and trace, then you are getting value of tau n, tau 3n. So see, 3 into 4, that is, what is its value? 4 into 3, that is 12. 2 into minus 1, that is minus 2.
Minus 2.
2 into 1, 2. And 4 into 1. So that is 4. Okay, in this way you can write down this one. Okay, after writing this, then find out the total composite, then use the reduction formula. What is reduction formula? So see, this is the reduction formula. Look at here. This is the reduction formula. Okay, if you want to applying reduction formula, so reduction formula is simply what you can do in the reduction formula. Reduction formula is this one. See, number of times irreducible representation I is equal to 1 upon h. H is a group number. Okay, sigma n is a coefficient. N is a coefficient. Character of reducible representation and character of irreducible representation, psi r. So this is the formula. That is called, you are getting number of times ith representation. Okay. So ni equal to, simply you can calculate using this formula. So now your target is to calculate number of times all irreducible representation. that is number of times you required A1. So A1 is already there. Okay, so you can calculate number of times A1, number of times A2, number of times B1, number of times B2. So what is group number? What is value of H in this character table? हेलो
G.
ना आप आए तो लेक्चर चालू हो गए પછી આવું હા હા લેક્ચર પૂરો કરીને આવું સારા બાદ હો હા હા so see here it is H
G.
is order of 4 yes the coefficient of E is 1 then C2 is 1 sigma V and sigma Vy so that is 4 so it is a 1 upon 4 now n is a coefficient so n is equal to you can say see here n is a coefficient so you are calculating a1 so you are just focusing on a1 only तो आपको ये तीन रिप्रेजेंटेशन से आप इस पे फोकस करना है वन इज यू कैन टेक a1 एक आपको जो ये a1 है उनके सारे कैरेक्टर इसको ये आपका इरेड्यूसिबल रिप्रेजेंटेशन हो गया ये सारे आगे जो लिखा है ये कोएफिशिएंट है 1 1 1 1 एंड यहाँ पे जो है दैट इज दिस वन इसको साथ में कैलकुलेशन मिलेगा okay so here this is first is a n that is coefficient of E is a 1 into character of a1 in a E is 1 into character of 3n that is here unshifted terms and trace multiplication value is 12 so you can put this 12 then it is a sigma so you can do summation plus again see coefficient C2 is equal to 1 into character of a1 in C2 is 1 into here minus 2 okay plus sigma v that is 1 coefficient sigma v extend character of a1 is 1 and here it is 2 plus sigma v yz it is 1 coefficient here it is 1 character and here it is 4 so your answer become number of times a1 is equal to 1 upon 4 here 1 into 1 into 12 that is 12 1 into 1 into minus 2 that is minus 2 1 into 1 into 2 that is plus 2 and 1 into 1 into 4 that is 4 so your answer become 12 by 4 that is 3 so you can say 3 times a1 okay is there any confusion or any query
No, sir.
okay see similar way you can calculate number of
सर
times
4 होगा ना 4 टाइम्स 7
12 by 4
प्लस 4 भी तो है
नहीं प्लस 4 है ना तो minus 2 plus 2 0 okay sorry 16 yes minus 2 plus 2 it is 0 so 12 plus 4 it is 16 by 4 it is 4 times a1 good this is the 4 times a1 right now you can go for number of times
I will be
a2
taking that under root 3n into consideration of calculating ni.
ये अंडर रूट 3 नहीं है टाउ 3n है टाउ इट इज आपने जो पहले उस टाइम पूछा था ना कि ये क्या है इसमें ये टाउ ओके दैट इज कॉल्ड रिड्यूसिबल रिप्रेजेंटेशन ये सेम यहाँ पे ये है टाउ 3n ओके
Okay, sir.
नाउ सी A2 के लिए आप कौन कौन सी तीन चीज लेंगे एक तो कोएफिशिएंट जो ऊपर लिखा था वो सेम रहेगा सारे के कोएफिशिएंट अभी टाउ 3 भी रहेगा 3n बट जहां आपने A1 लिखा था सी A1 उसकी जगह आप A2 के कैरेक्टर कंसीडर करेंगे सो कोएफिशिएंट ऑफ E इज 1 कैरेक्टर ऑफ A2 इन E इज 1 देन 12 कैरेक्टर ऑफ 3n plus then summation next you go for coefficient of C2 is a 1 into A2 is a 1 into minus 2 plus 1 into minus 1 into minus 1 into minus 1 into 2 plus 1 into minus 1 into 4. ओके आपने जब यहाँ पे a1 लिया था उसकी जगह पे a2 कंसीडर करना है, बाकी तीन को आप छोड़ दो। इसका मल्टीप्लिकेशन कैरेक्टर ऑफ 3n के साथ करो और साथ में कोएफिशिएंट भी है। चलो इसका आंसर कितना आएगा? 12, ये -2 हो जाएगा, ये भी -2 है और ये -4 है। कितना आंसर आएगा? 12 minus 4 minus 4, that is 12 minus 8, that is 4 by 4.
4. 1 on the 1.
Yes, it's a 1. So it's a 1 time a2. Good. Now see number of times b1. अभी डायरेक्ट लिखेंगे 1/4 डायरेक्ट आप मल्टीप्लिकेशन लिखवाओ 1 into 1 into 12, that is 12. Next 1 into -1 into -2 कितना होगा? 1 into 1 minus 1 into -2 कितना होगा?
2.
Plus 2. Okay, then 1 into 2, again 2. Then 1 into -1 into 4, that is
4.
-4. 1 into -1 into 4, that is -1, -4. So कितना आंसर आएगा?
3.
3. Yes, it's a 3 times 3 आएगा। +4 -4 0 हो जाएगा। Okay, fine, it's a 3. So 3a, it's a 3b1. Good. Now what's about b2? Number of times b2? 1/4. चलो b2 के लिए यहाँ पे 1 है, कोएफिशिएंट b2 भी 1 है और 12. So 1 into 1 into 12, that is 12. Then 1 into -1 into -2, minus plus 2. Then 1 into -1 into 2, that is -2. And last one 1 into 1 into 4, that is +4. So +2 -2 cancel out. So 16/4, that is 4b2. So आपके सी टोटल मोड कितने है? ये टोटल मोड ऑफ वाइब्रेशन, टोटल मोड्स में रोटेशनल, ट्रांसलेशनल, वाइब्रेशनल सारे आ जाएंगे। दैट इज 4a1 प्लस 1a2 प्लस 3b1 प्लस 4b2. This is your total mode of vibration. सी टोटल मोड के लिए फॉर्मूला ये है 3n, AB2 टाइप मॉलिक्यूल के लिए, ऐसे बेंड शेप मॉलिक्यूल के लिए। तो यहाँ नंबर ऑफ एटम 4 है, तो आप n इज इक्वल टू 4, इसमें इस फॉर्मूला में n इक्वल टू 4 आप वैल्यू सबमिट करेंगे। सो यू विल गेट टोटल मोड ऑफ वाइब्रेशंस आर 12. यहाँ पे भी 12 है। सी 4 + 1 + 3 + 4, दैट इज 4 + 1 + 3 + 4, दैट इज 12. आपको तो हायर एक्टिव मोड ऑफ वाइब्रेशन चाहिए, वो 3n माइनस नॉन लीनियर मॉलिक्यूल के लिए 6a फॉर्मूला है। तो 12 - 6, दैट इज कितना आएगा आंसर? 6. यस, वो कैलकुलेट करना है। नाउ यू टेल मी, सी दिस इज ए टोटल मोड ऑफ वाइब्रेशन। अभी इसमें ट्रांसलेशन भी होगे, रोटेशनल भी होगे, वाइब्रेशनल भी होगे। तो हम क्या करेंगे? आपको वाइब्रेशनल चाहिए, सी वी वांट अ वाइब्रेशनल मोड। तो हम क्या करेंगे? टोटल मोड है उसमें से इसको माइनस कर देंगे, रोटेशनल एंड ट्रांसलेशन को माइनस कर देंगे। ओके, सो यू विल गेट वाइब्रेशनल मोड। ओके,
Yes, sir.
सो वाइब्रेशनल मोड इज इक्वल टू, आपके पास टोटल मोड ये है, सी 4a1 प्लस a2 प्लस 3b1 प्लस 4b2 माइनस रोटेशनल। रोटेशनल के लिए आपको रोटेशनल कंपोनेंट देखना है। रोटेशनल कंपोनेंट मींस Rx, Ry, Rz। रोटेशनल कंपोनेंट किसको बोलेंगे? Rx, Ry, Rz।
RY,
वो कौन कौन से मोड में आ रहा है? A1 में है,
A2, B1, B2.
यस, A2, B1 एंड B2। सो यू जस्ट सब्सट्रैक्ट हियर A2 then B2 minus B1. Sorry, B1 and B2. Good. So this is the rotational mode you have subtracted. Then you can subtract translation component. Translation means XYZ. वो किस में आता है XYZ?
A1, B1 and B2.
A1 है और A1 है, उसमें यहाँ पे Z है और B1 and B2. So see minus A1 minus B1 minus B2. So what is your answer? Vibrational mode is equal to 4A1 है, उसमें से एक A1 निकल जाएगा यहाँ पे, तो कितने बचेंगे? 3A1. A2 एक है, यहाँ इसमें से एक A2 आप माइनस कर दो तो वो तो कैंसिल हो जाएगा. 3B1 है, उसमें से 2B1 माइनस कर दो, so it's a B1 simply. 1B1. B2 कितने हैं? 4. उसमें से 2 माइनस कर दो, B2 आप 2 माइनस कर दोगे तो इट्स 2B2. चेक करो 6 आ गए. 3 plus 1 plus 2 that is 6. हायर एक्टिव मोड ऑफ वाइब्रेशन इसमें 6 था. 6 आ गए? Yes or no?
Yes, a 6.
Yes, it
3
is a
plus
6.
1 plus 2.
Yes. So see, इसके लिए आपको कैरेक्टर टेबल देना चाहिए. आपको सिर्फ प्रोसीजर क्या है? फर्स्ट यू राइट डाउन.
ट्रांसलेशन सर एक बार और बता देंगे
क्या?
रोटेशन एंड ट्रांसलेशन A2.
तो रोटेशनल में क्या करना है आपको? RX, RY, RZ है ना, वो रोटेशनल कंपोनेंट है. जो भी रिप्रेजेंटेशन में वो आता है वो RX, RY, RZ मोड हो गया आपका, वो रोटेशनल हो गया. सी यहाँ पे देखो A2 है, उसके सामने RZ है, यहाँ पे ये RZ है, उसके सामने जो रिप्रेजेंटेशन है उनका नेम A2 है, तो A2 इज ए रोटेशनल कंपोनेंट. यहाँ RY है तो उसके सामने यहाँ पे B1 है, सो इट इज ए रोटेशनल कंपोनेंट. यहाँ पे RX है तो उसके पास में बिल्कुल यहाँ पे B2 है, तो वो भी रोटेशनल हो गया. ओके. इसी तरह XYZ जो है ना, वो ट्रांसलेशन कंपोनेंट है. तो आपको क्या करना है? XYZ जिसमें भी है उनका XYZ जो जहाँ पे भी है उसका जो कैरेक्टर रिप्रेजेंटेशन है उनको ही लिखना है. Z है तो इसमें A1 है, X है तो उसमें B1. ओके. और आपको प्रैक्टिस करेंगे तो और क्लियर हो जाएगा. सी सेकंड एग्जांपल जो है वो सिमिलर ही है. हेलो, हाँ बोलो बोलो. आज चालू है प्रोसेस हो लेने बैठे હું ફોન કરો ને લેક્ચર માં. Now next is see same calculations if you want to do for cis 1,3-butadiene. So this is a cis 1,3-butadiene. Here it is a single bond, here it is double bond, CH2 double bond, CH2 double bond CH, single bond CH, double bond CH2. See, this is a cis butadiene. So again, see point group is C2V. Here you can have a single bond. So again, see point group is C2V. So this is the C2 axis, remember. Again, see this plane is, you can say, this plane is called sigma xz. And plane of your paper, that's called sigma, all the atoms are there in the plane of your mobile. That is called sigma yz. So how many atoms are there? Total number of atoms?
10.
So it's 3 plus 2, that is 10 atom. Yes. So first you write down, see, unshift atom. Okay, unshift atom.
25. Yes.
Then up unshift atom become. See, if you do E operation, so all 10 atom remains unshift. Okay. If you do E operation, then all 10 atoms remains unshift. So you can have a 10 unshift atom. Now you can do rotation about C2 axis. So how many atom remains unshipped? C2 axis middle में से pass होती है. This is your C2 axis.
0.
सारे ही shift हो जा रहे हैं सर. 0.
Yeah, unshipped atom become 0. All the atoms can change their position. Now if you go for sigma Vxz, that is mirror plane, reflection plane, middle वाला plane जो है xz लेके ये plane, तो कितने atom unshipped रहेंगे?
0.
And if you go for sigma yz, then all 10 remains unshipped. Is it clear?
Yes, sir.
Okay, now next job is to write down trace. How to write down trace? Trace is simply the summation of character of irreducible representation which having translation component xyz. तो xyz कौन कौन से रिप्रेजेंटेशन में है? एक तो a1,
A1, B1 and B2.
b2, तो इनके कैरेक्टर का समेशन करो. 1 plus 1 plus 1
3.
3. Then 1 minus 1 minus 1.
1.
Okay, 1
Minus
minus
1.
1, yes. Then 1 1 minus 1. It is 1.
-1.
नहीं, 1 1 minus 1, तो 1 हो जाएगा. ओके, उसके बाद 1
Yes,
minus 1 1, अगेन 1. ना उसके बाद आपको क्या करना है? मल्टीप्लिकेशन. 10 into 3.
30.
Yes, it is 30. 0 into minus 1, 0.
0.
Again 0.
0.
And
And 10. 10.
10. Good. Oh, yes. Now you go for calculating number of times A1, number of times A2. Okay, so do the calculation and then we check the answer. You can try it by yourself. Okay, after 5 minutes we see it. Hello? सो आप इनको आराम से है ना, वो इसको सॉल्व करके हम फाइनल आंसर चेक करते हैं. उसको इसको देखो और उसके बाद एमोनिया के लिए कैरेक्टर टेबल है. ओके, सो यू जस्ट ट्राई इट बाय योरसेल्फ and then try it for ammonia. So after 10 to 15 minutes I will come and report you. अब एक काम करो, इसको मैं आपके ग्रुप में भेज देता हूँ ये और एमोनिया, और आप शाम को जब मिलेंगे ना तो आप ट्राई करके इसको कंप्लीट करके रखिए, है ना. अरे एक
Yes,
मीटिंग
sir.
है ना मीनवाइल, तो इसको स्टॉप करना पड़ेगा. तो मैं आपको भेज देता हूँ ये जो दोनों कैरेक्टर टेबल है वो आपको फॉर्मल्डिहाइड के लिए और सॉरी 1,3 ब्यूटाडाइन के लिए और एमोनिया के लिए कैलकुलेट करके आप शाम को हम उसको रेक्टिफाई करेंगे 6 बजे. ओके,
Yes, sir.
या तो आप फ्री टाइम में कर सकते हो इसको सॉल्व. So now I stop the meeting here, okay, and then we join at 6 o'clock today evening. Thank you very much.
Thank you, sir. Thank you.
Yeah.